Continuing chapter 7. So we've had a little bit of an introduction to what oceans are, what they do for Earth. Then we talked about how waves travel in the ocean. And now we're going to kind of talk about imagine what happens when you drain all the water on the ocean and then what's left behind. So what is the actual topography of the ocean floor? And there's actually a really cool series, by the way, called Drain the Ocean. Which is really cool. But this one, our first one that we're focusing on, this section 3, is shallow marine environments. So when we think of shallow, imagine the water is not very deep, right? We're going to focus particularly on beaches. There are other shallow marine environments like you see here, like a coral reef and things, but we're going to focus on beaches. But anytime you guys hear that word marine, it's things that are part of or from the ocean. That's what marine means. So things that are part of or from the ocean. When we think of that water that's in a shallow area, we think of beach. Going to the beach, right? It's actually a little bit more complex than that. So we're familiar with the beach, but as you can see in this diagram here, there is other parts to it. What the beach is the area of coastal sand between the low tide line and the line of permanent vegetation. So oceans experience tides, which means the water flows in and the water flows out, right? Comes in and goes out, all because of that gravitational pull between the moon and the earth. So if you live near a location where there's a beach, the water is not going to be at the same every day. It's going to come in and it's going to go out, high tide and low tide. So the area of sand between the low tide and the line of what we would consider permanent vegetation would be the beach. And you think about plants, permanent vegetation. So that means that's the area that's not going to be greatly disrupted by wave action, or if there's storms come along, those plants are kind of in a nice little safe harbor zone. So that's what a beach is. So if you look at the diagram here, you have different parts to the beach. You have technically what's called the back shore, and then you also have the foreshore. So those two parts are part of what we call the beach. And that would be, imagine now that line, the water line going back out to where you see that bottom dash line is, that would be the low tide line. The high tide line would be the dash line that is kind of near the top of that diagram. So near low tide, the water would go out to where you see on the bottom of the foreshore is that arrow on the far left-hand side of the foreshore term. That would be low tide. So this area where the tides move, come and go, is called the intertidal zone. So the back shore is the part of the beach above the high tide, which is only submerged during storms. So in the back shore area, that would be a safe place. If you're setting up camp for the day, safe place. Not unless a storm is coming. If a storm is coming, now that water is going to come up there. But the back shore, the water is only going there when it's stormy out. The foreshore, that's the area that lies between the high and low tide lines. So it's between those two dash lines. Another term for that is they call it, like I have on the top part here, the intertidal zone. So intertidal zone is the area that exists there between tides. Sea level is another term we use a lot when we're talking about marine environments. So the average ocean height between the high and low tide levels is going to be sea level. So when you hear sea level, keep in mind the water rises and it recedes every day. So what's the average? What's the in-between? That's going to be sea level. So just looking at overall, now in the future, hopefully when you look at this, it's not just the beach. We have other areas, as you can see here, and now even another area, the offshore that you see, which is beyond the shore face, on that beach area. You'll also notice in that area, it's going to be more bumpy. So waves take sand and they move that sand. Heavier particles are going to settle out to the bottom. Finer particles are going to get carried away. What's actually left, and this is going to come up on a slide in a little bit here, is coarse sand. But you'll notice you're going to get a difference there when you're in the offshore. So if you were walking out and you kept moving, you would start to notice a big difference in what it would feel like on your feet there. So sand is obviously the most obvious feature of a beach. They're rounded grains, and it's because we have thousands and thousands of years of heavy wave action taking those sediments, and then essentially it's almost like nature's rock tumbler. If you've ever seen a rock tumbler before, you put rocks in there and a month later you got these nice smooth stones. just speeding up the process is all. You'll notice on this slide here that beaches can be different color, their sands can be different color. It's all about what's carrying the sediment there. What carried it there, depending upon the type of rock or mineral that's in the area, you're gonna get different colors. Like the one in the lower right-hand corner there is black. That's a big indicator to us there's probably volcanic activity in that area, and that is actually a picture from a beach in Hawaii, which looks like, oh, it's really dirty, but it's just that rock happens to be basalt. Tidal flats are similar to beaches, and they're in an area where they're going to experience water action. But the big difference here, you'll notice just looking at this picture here, if you're walking along a tidal flat, it's not as nice as when you're walking along the beach. Tidal flats are flat. They're also really muddy. So they're a muddy area in the foreshore. We often find them around salt marshes. They're also located in an intertidal zone, but it really is dark, sticky mud that you see in these tidal flat areas. Once again, here's a picture you can see on the side. So it's going to be between high and low tide. It's that area that's exposed. If you came back here in a few hours, these people wouldn't be able to walk there. There would be water covering that area. So how are beaches and tidal flats alike? Tidal flats and beaches are both covered by sediment. So they both have sediment, which is carried there by streams and rivers from the mountains and other high places. The difference is what happens to that sediment after it arrives in those beaches. And really waves are the key difference there. So waves are the key difference between tidal flats and beaches. Beaches are affected by really strong wave action. So you're in an area where strong wave action exists. Tidal flats, that is not the case. You're just going to have a nice gentle tide coming in and then going out. And these waves change the size of the sediment particles. So that's why you're going to get sand versus mud. So talking about wave action at beaches, and I mentioned this a little bit before, the largest particles of sediment are usually going to be heavy enough, they're going to settle out to the ocean floor. The smallest particles and then the broken grains are carried out to sea with the waves and ocean currents. What's left is what we call the coarse sand. Two really common rocks or minerals that form beach sand are quartz and feldspar. They're really hard. So that means that they have the ability to hold up to, water just continually having that pounding action on waves. The particles just eventually get broken up into smaller particles. They're not going to be dissolved into the water like some other rocks or minerals might be dissolved into the water. In the United States in general, we get a little bit different things happening with the wave action in the summer. The waves have a tendency, because of global wind patterns, to be more gentle, so that those gentle summer waves will actually carry sand from the deeper water onto the beaches. And in the winter, we get the opposite happening. We have usually stronger wave action in the winter time, which will carry sand back out to deeper waters. So you see there's sort of this cycle happening here. Summer bringing sand in, winter carrying it away. In a perfect world, it would be this nice relationship where whatever sand was brought in the summer comes out in the wintertime. But that's not how weather works, as we know. You're going to get changes sometimes where you're going to get more sand in the summer, maybe less sand in the summer, more sand carried out in the winter, less sand carried out in the winter. So it can affect certain areas. And if you're talking about being in one of those locations where, let's say, the sand at the beach is getting disrupted, you can really start to see the economic importance of maintaining beach in an area. If you're a community that relies heavily on tourism, you need that beach there for your tourist to be able to visit. So beaches never completely actually wear away because rivers and streams bring new sand from the mountains to the beaches. Thing too that's kind of weird is the sand doesn't actually stay in one location. It's moving. So even though, we can sit and look at a beach and go, yeah, it's always been that way. They're actually a quite moving geographical feature. A headland is a place on a shore that sticks out from the coast, so it's going to get a lot of wave action. Sometimes some of that sediment is strong enough that it's not going to get carried away. Those rocks are hard, so they're not going to get carried away, and they form these features that you see called sea stacks, places where the shore resists wearing away. See these all the time in movies, especially when we have like the pirate map and we hold up this medallion and the sea stacks will line up. I'm pretty sure I'm thinking of Goonies right there for that. But that is those features. There was erosion around the area. Those rock features were strong enough to be able to withstand the erosion, and that's what's left are those sea stacks. So sand actually flows along the coast. It moves along the coast. Now the coast is the boundary between land and the body of water like the ocean. So coast is a term, it would be similar to beach, but it's just essentially encompassing everything there. So the boundary between land and water like the ocean, the whole area would be considered the coast. So because the sand moves or it flows along the coast, of course we have to name it, and that is called longshore drift. So this sand, as it moves along the beach, is called longshore drift. So the movement of sand along a coast. And like I said earlier, if you're a community that relies heavy on your beach area there, you want to make sure, what can we do to control this? We need to retain our sediment here so that we can keep our beach. If you're a homeowner that has a home on that beach, we need to figure out, what can I do to make sure that my beach is going to be here next to my house? So longshore drift shapes beaches. Now, if you look at this picture, what actually happens is we have prevailing winds will actually come in at the coast at an angle, because that's how it happens with global wind patterns. Remember, in an angle, right? We don't like straight lines because of Coriolis effect. So longshore drift shapes beaches because waves approach the beach actually at an angle. They will carry sand grains in the same direction the waves move. So when you look at this picture here, those red arrows are going to be showing you the direction of longshore drift. So that sediment is going to be moving and moving and moving along that coastline in the direction of that brown arrow there. So the waves come in at one direction, and we actually call that the upwash, and then they leave the beach at technically a different angle, the backwash, just like you can see in the picture there. So the red arrow would be the upwash, the white arrow would be the backwash. So this process causes sand to move along the beach, making the coast or the beach area something that actually changes or moves. So what do we do as humans to try to figure out how can we prevent this from happening? So a couple of features that we use that we can build in areas to try to stop this sediment from moving. One of them is called a jetty, and that's what you see just to the picture that's in the middle there, where the people are walking and down it. It's a barrier built to control or slow down ocean currents along a coast. If you can figure out how to manipulate those ocean currents, how to manipulate those waves, not let them carry that sediment in the first place, then that would be something that would prevent it. The other feature is called a breakwater. It's a barrier to longshore drift that protects harbors. So if you look at the picture, they sort of show you a generic, cartoon breakwater picture there. The one on the bottom is another one. Sometimes you will see these much bigger, like coming into a harbor. So what that does is it stops that wave action. There is a bit of a negative effect that can happen because of this, and you see it happening up there on that cartoon type picture. So what happens is you'll actually get sediment that gets built up behind it. So what then happens is we have to bring in a dredging system, and they will take and literally dredge the sand out of there and move it to other locations, and it has to be done. And we see this happening if you've ever paid attention into Lake Superior and the harbor there. When you come in the summertime, oftentimes you see dredgers in there moving sediment. So you stop wave action, but sediments get deposited because you don't have wave action in that area moving that actual sediment. So we have to go in there and actually dredge. Finally, continental shelf. At the edge of every continent is something that we see, it's called the continental shelf. And if you look at the picture there, you can see why it's called that. So if I see where the beach is, every continent has what we almost looks like a shelf. So you have a shelf coming off the continent, and then it's going to drastically drop off into what we call the abyssal plain in the ocean. But that area there just beyond the beach is called the continental shelf. So the ocean bottom that extends from a coast or shoreline to what we call that sloping area is the continental slope, and then it goes off into the abyss there. Sand actually drifts down the steep face of these, creating those sort of like canyons or valleys that you see in there. They're called submarine canyons. And if those are big in an area, those submarine canyons, they can really pull quite a bit of sand with them once again, which can be a problem for those areas. So lots of interesting features in a shallow marine environment.